factor first and then set equal to 0. Factor in x squared plus 4x minus 5. Two numbers again that multiply to get negative 5 and add to get positive 4. That would be x plus 5 and x minus 1. And again, setting these factors equal to 0, x plus 5 equals 0, and x minus 1 equals 0. We'll get the two vertical asymptotes, x equals negative 5, and also x equals positive 1. For the horizontal asymptotes, again, we'll look at the degree or exponents for the numerator and denominator. Having a single 3 has no variable or x's, so the degree of the numerator will be 0, and the degree or highest exponent would be 2 for the denominator. So the numerator is lower than the denominator, which means the horizontal is y equals 0. And looking for any holes in this graph, we have just a single 3 in the numerator, so there's no factor to cancel, so holes would be none. Graphing from here, we can draw the xy axis. Two vertical asymptotes, so we'll draw two vertical lines, one at negative 5 and the other at positive 1. The horizontal asymptote, y equals 0, will be the dashed line going across the x-axis. In this question with two vertical asymptotes, instead of 4 sections to graph, now we have 6 sections to graph. Each section again will either have a curve on top or a curve on bottom of the graph. The middle sections will be parabola shapes, either going up or down, and the right side will either have a curve on top or curve on bottom. Graphing the left-hand side, again we can do a t-table to figure out if the graph is on top or bottom of each section. The first vertical asymptote's at negative 5, so we can pick a number to the left of negative 5, such as negative 6. 3 will be on the numerator from the original equation, and plugging in a negative 6 for the x values, x squared, or negative 6 squared would be 36, plus 4 times a negative 6 would be minus 24, and minus 5. Solving this out, we'll have 3 divided by 36 minus 24 would be 12, minus 5 would be 7. So our first point would be negative 6, and the y value is 3/7, or is a positive number, which means the graph will be on the top half of the left-hand section. And again, the graph will curve and go next to or parallel the asymptotes. For the second section, the middle section, we could pick any number between negative 5 and positive 1. Nice easy number again would be 0. Plugging a 0 into the original equation, 3 will be the same on the numerator. The x's will be 0, and we'll be left with a minus 5. So 0 and 3 over negative 5, or negative 3/5. Again, a negative number will be below the x-axis and below the horizontal axis. Since we have vertical asymptotes on both sides, the graph will curve or go parallel to each of the asymptotes and then curve back down since we have a negative number. And the last section of the graph, the right-hand side, the vertical asymptotes at 1, so a number to the right of 1 that we can select would be 2. Plugging a 2 into the original equation, we'll have 3. 2 squared would be 4. 4 times 2 would be 8, and minus 5. 3 over 4 plus 8 would be 12, minus 5 would be 7. So we'll have a y value of 3/7, or a positive y value, which again means the graph is above the horizontal asymptote. And that would be the graph for the section. First section of notes today is titled Direct, Inverse, and Joint Variation. There's three types of variations, or how numbers change. They could be direct variation, inverse variation, or joint variation. Three different formulas for direct variation. The formula is y equals k times x. X and y would be variables. K would be a constant or a number. Inverse, the second type of variation. Formula would be y equals k divided by x. Again, x and y are variables. K is a constant or a number. And the last type of variation, joint or jointly. Y equals k times x times z. And jointly there's three variables, x, y, and z. And again, you have k as a constant or a number. The first problem we'll solve is if y varies directly as x and y equals 15 when x equals 3, find y when x equals 12. So again, y varies directly means we'll be using the direct formula, which is y equals k times x. Y equals 15 when x equals 3 means you can plug a 15 for the y and a 3 for the x. And we want to find out what y is when x changes to 12. When you plug 3 and 15 in, you can now solve for k or solve for the constant. Divide by 3, and k is equal to 5. K again is a constant. It stays the same throughout this problem, but can change for future problems. If we go back to the original equation, y equals k times x, we want to find out what y equals. We found k is equal to 5, and we want to find y when x equals 12. So the answer to this question would be y equals 60. Y equals 15 when x equals 3, but when x changes to 12, the y value will change to 60. We'll do one more problem for this section. Next problem, if y varies inversely as x and y equals 5 when x equals 10, find y when x equals 2. So again, y varies inversely, means we'll use the inverse equation, which again is y equals k divided by x. Y is equal to 5 when x equals 10, means we can plug a 5 in for the y and a 10 in for the x. Solving for k, you can multiply both sides by 10. And 50 is equal to k, or k equals 50. Keep in mind, we're not solving for k. We want to find out what y is. Find y when x equals 2. So going back to the original equation, y equals, k we know is 50, x is 2, dividing out, y equals 25. So again, y equals 5 when x equals 10, but if x changes to 2, if it varies inversely and changes to 2, y will change to 25. The first function is a v-shape. All v-shapes are absolute value. The second function is in the form y equals k times x, which would be direct variation. The last function, y equals 4 divided by x, is in the form y equals k over x, which would be inverse variation. First section of notes today is titled Solving Rational Equations. Question for this section is 9 over 28 plus 3 over y plus 2 equals 3 over 4. To solve this rational equation, we need all the denominators to be the same. For example, if this one's 28, we can change this one to 28 by multiplying by 7. This middle fraction also has to have 28 also, as just a coefficient number. So we'll have to multiply that one by 28. Also, this fraction has a factor of y plus 2, which means each fraction has to have a factor of y plus 2. From here we can multiply, distribute out, and combine the fractions. For example, 9 times y plus 2 would be 9y plus 18. 28 times 3 would be 84. And 3 times 7 would be 21. And we can distribute this 21 to 21y plus 42. The fraction on each of these is the same. It would be 28y plus 2. 28y plus 2 and 28y plus 2. All the fractions have the same denominator and they're all equal. So what we can do is cross off those denominators or ignore them and just solve the top equation. 9y would come down. 18 plus 84 would be 102. 21y plus 42 would come down. We can subtract 21y on both sides. It should be negative 12y. we can subtract 102 on both sides, which would be negative 60. And we can divide by negative 12. And the answer would be y equals 5. The next section of notes is titled Elimination of Possible Solutions. First question is x plus x squared minus 5 over x squared minus 1 equals x squared plus x plus 2 over x plus 1. Same idea as before. We have three terms or three fractions. Before we can add or subtract the fractions, they have to have the same denominators. In this case, one of the denominator's factors, x squared minus 1, is the same as x plus 1, x minus 1. So in this case, these two fractions have x plus 1, which means this first term, x, also has to have a x plus 1. The second fraction also has a x minus 1 in the denominator, so this first fraction has to have x minus 1, and the second fraction has to have x minus 1. We did multiply by x plus 1 on the bottom of this fraction, so we'll have to multiply by x plus 1 in the numerator, and also x minus 1 in the numerator. This fraction we multiply by x minus 1, so we have to multiply the numerator by x minus 1. The second fraction we did not multiply anything, so x squared minus 5 would stay the same. Multiplying these out, x minus 1, x plus 1, that's the same as x squared minus 1. And then we're multiplying by x. And the denominator is x plus 1, x minus 1. The second fraction did not change, x squared minus 5. We'll leave the denominator in factored form, x plus 1, x minus 1. And the second fraction, we can begin to multiply this out. This x will be distributed to each of these terms, which would be x times x squared, x times x, and x times 2. We'll also have negative 1 times each of these three terms, so that would be a negative x squared, a negative x, and negative 2. This 2 appears actually 2 times x, so that should be 2x. That's the numerator, so the denominator again should be x plus 1, x minus 1. Again, once all your denominators are the same, you can cross those off or ignore them for now. At the end of the problem, we'll get back to the elimination of possible solutions, which will look at the denominators. This numerator we can distribute, x times each of these. That'd be x cubed minus x. X squared minus 5 stays the same. Equals, we have x cubed. The x squareds actually cancel out, positive x squared and negative x squared. 2x minus x would just be 1x or plus x, and minus 2 on the end. Solving this equation, the x cubes cancel by subtracting on both sides. And then we're left with x and x squared. So what we'll want to do is bring everything to one side and then see if it factors. So we can subtract the x over and add the 2. We'll put x squared first. Negative x minus x would be negative 2x, and negative 5 plus 2 would be negative 3. Nothing left on the right side, so that would equal 0. When we're left with x squared and x, you want to check and see if it factors. In this case, it would factor to x minus 3 and x plus 1. From here we can solve, get our two answers, x minus 3 equals 0 and x plus 1 equals 0. Add 3 to both sides, x equals 3. Subtract 1 on both sides, x equals negative 1. These are two answers. In this case, these are two possible answers. What we have to do is look back at the denominators that we canceled out. If you remember, anytime a denominator is equal to 0, it's undefined, and undefined would be no solution for that question. If we have a 3, x equals 3, 3 would be okay in each of these denominators. But if you plug a negative 1 in to the first denominator, negative 1 plus 1 would be 0, and the denominator would equal to 0, which would make this question undefined. If you have any answers that give you 0 denominators or undefined, we're going to cross those off and eliminate them as a possible solution. So instead of two answers, this question only has one answer, x equals 3. And again, to check those, plug them back in. If any of the denominators equal to 0 in the original question or the factored questions, then you can cross off the answer that makes it 0, and the ones that are left are the only possible answers. Title of the next section